Hello everyone, I am Sweetie Pinjani. Welcome you to Sweetie Speaks official YouTube channel. This is System Verilog Essential series where we are learning some very important concepts in System Verilog which people find it very difficult to understand or which they feel very confused about, and we are trying to understand all of them in very simple, easy to understand language along with the coding examples. Today we will take one such concept in System Verilog, which is callback. A lot of people get confused while understanding callback, and a lot of people feel that it is very difficult to understand. No, it's not. I'll explain it to you with the help of coding examples in very simple and easy language. Let's get started. Let's understand what is callback. In very simple words, I can tell that callback is nothing but there are some empty methods. There are some empty methods. They don't contain anything to which we do a call. If there is a driver class, a driver is doing a call to this empty method. Now you will say, why will a driver call empty method? Actually, these empty methods are just providing the skeleton. You can extend from this empty method and create your own method to do whatever you want to do. These are just providing you skeleton and a mechanism to call to a particular method to do something. What is the purpose of having this empty method to which you will extend and then you will call it back? Why do we do this? The main purpose is, say I have a driver code. In that driver code, I want to do many different type of transactions depending on my test case scenario. But I don't want to modify the actual driver code. I just want to modify the behavior of the component, behavior of the driver. What is the aim of the driver? To do transaction. Now say in one particular test case, I want to drop my transaction. In another particular test case, I want to inject some kind of error in my transaction. In another test case, I want to add some delays to my transaction. These are different behaviors of the same component, which is driver. I don't want to touch the driver code. The driver code should remain same, and depending on my test case, I should be able to do whatever I want to do to with the help of driver without touching the driver code. In such scenarios, these callback methods are helpful because what we will do, whatever thing we want to do, we will put it inside this callback method instead of putting in the driver, so that the driver code remains untouched. I'll show you this with the help of coding example. There it will be more clear. For now, remember the main use is you can alter the component behavior but without modifying the actual code of your component. This is the major purpose of the callback. What happens in the callback? A method of class is implemented with calls to the dummy methods. For example, you have a component driver. In that driver, you will have some methods. Say you have a method to transmit your transaction. In that method, what you will do, you will also have calls to the dummy method, which is your callback method. This dummy method can later on do whatever you want to do. There will be a class which will extend from this dummy methods, and later on if you want to drop the transaction, you will do. If you want to delay the transaction, whatever you want to do from to that transaction, you will do. The main method which is inside your driver class will have the calls to this dummy methods. This is the first point. Second point is a user will extend this class. Whatever dummy class you have, you will extend and implement the dummy methods whenever needed. The methods are dummy for now, but later on, say in your test case, I want to drop the transaction. I'll extend from the class and implement this dummy method. I'll put some code in the dummy method. I'll put the code to drop the transaction. With that, what happened? I did not modify the driver code. I just extended using this dummy method. I created a transaction which will get dropped. without touching the driver code. You can consider these dummy methods or calls as a hooks. They are a hook method call. This is then what happens, there will be a user defined code inside this. Using this dummy method calls, we will execute a user defined code instead of the empty callback method. We will not actually execute the empty method, we will implement this empty method as and when required. For now they are empty so that we have a mechanism to call to something without changing the driver code. They are providing a mechanism to add something upon your driver without editing the code of the driver. Later on, you will not actually call this empty method. They are just hooks. Later on, you will have the user defined code. I will show you this with the help of the coding example. I'll explain you each and every line of the code. There it will be very much clear. Some things which you have to remember, these dummy methods are called as callback methods. Calls to the dummy method is called callback. The methods are called as callback method, and the calls to these methods is called as callback. When you call these methods, that is called as callback. Implementing the callback method is not mandatory. It is possible you will leave it empty, you don't want to do anything specific. That is also possible, but still at least you have the hook. If you want to do anything, you will do. If you don't want to do anything, you will keep it as it is. Let's understand the main need. I told you the purpose. Now I will explain you the need of this callback with the help of proper examples. What I want to do, I want to create a verification environment that can be reused for all tests. I don't want to modify my component every time I run a particular test. I don't want to do that. I want to create a reusable verification environment. All the components which are driver, monitor, everything should be reusable. This is the main thing. And as I said, these callback methods are actually a hook. For example, you want to inject a new code without modifying the original class. Say you want to add a new code to the driver class without modifying the original driver class. You just want to inject a new code, inject a new error, or as I said, delay the transaction, drop the transaction. This callback mechanism is just providing you a hook to do that without touching the driver class. I'll explain you with the help of one use case scenario now. Consider that you want to do certain things to the transaction. The main aim of your driver class is to transmit the transaction. Consider this example. You have a driver class. Its job is to transmit the transactions. With these transactions, you wish to do certain things. What these things are? First, you want to inject some errors. Second, you want to drop the transaction. Third, say you want to delay the transaction. You want to synchronize the transaction before transmitting. You want to put this transaction in the scoreboard for comparison or anything, whatever you want to do in the scoreboard. You want to put this transaction in the scoreboard. You want to do the functional coverage collection. Or if you want to do any of these, what can you do? The driver, you will not touch the actual driver code. The driver just needs to call back a routine defined in the top level list. Driver will just call back. There is a routine, there is a callback method which is defined in the top level list, and your driver will just call to that method. And the routine can be defined differently in every test. In every test, this routine can be different. Say in one test I am dropping the transaction, in another test I am delaying, in another test I am injecting the errors, in another test I am synchronizing the transaction before transmitting. In every test you can define this routine different. The test can add the new functionality using the callback without editing the driver class. Simple to understand. You have a driver class. Main aim of the driver class is to transmit the transaction, but you don't want to transmit similar kind of transaction in every test. In one test you want to inject errors, in another you want to drop, in another you want to delay, in some test you want to synchronize the transaction before transmitting. All these things can be done in different tests by using the callback. This is the main need of the callback. We understood what is callback, we understood the purpose, the need. Now, with the help of the block diagrams, let me explain you the flow of callback. We'll also see some code. I'll explain you each and every line of the code. Let us understand. First, I'll show you the driver code. Driver is one of the components of UVM, and even in system verilog you will have a component called as driver. It is a test bench component which will drive your inputs. There is a task inside your driver, run. This is your task. Inside the driver, there is run. What this task is doing, you have a forever loop inside this. It is first calling pre-trans. It means before doing the transaction, I want to do certain things. That things I'll do with the help of pre-trans. Then I'll transmit the transaction. Then after transmitting the transaction also, I want to do some things. That I will do with the help of post-trans. That's it. In the run task we are doing something before doing transaction, we are transmitting the transaction, then we are doing something after the transaction. That's it. What are the things you can do before the transaction? One example is, I want to delay the transaction, I'll add some delays and then I'll transmit. I want to synchronize the transaction before transmitting. What can be done post transaction? Maybe after doing the transaction I'll send it to the scoreboard, I'll do coverage collection. These are some examples. There can be a lot of things which you can do. For your understanding, I'm giving you a few simple examples. Before doing the transaction, I want to do some things. After doing transaction, I want to do some things. There is a callback. These two methods, which are pre-trans and post-trans, are the callback methods. This is the pre-trans. Here, whatever you want to do before doing the transaction, you will have that code. And then it will return the transaction to your driver class. It will perform whatever you want to do to the transaction. It will give that transaction to the driver so that it can transmit. After that, what will happen? Again, you have another callback, which is the post trans. After doing the transaction, you want to do something on it. You will do it with the help of post trans callback. And then you will get that transaction. This is how the callback flow happens. This is the main class and this is the callback. You will call this particular method. This is the callback method, pre-tran. You will have a call to this method inside your main class. Similarly, this is another callback method. You will have a call to this method in your driver class. These are callback methods, and this code where you are calling the method is called as callback. This and this is called as callback. Simple. Now let us understand what are the steps for doing callback. First, you have to create a callback in the top level test. Whatever callback methods you have to create it in the top level test. Then what will happen? You will call the callback task from the driver. Consider the same example which I showed you. In this case, you have to call back from the driver. You want to do some things to the transaction before transmitting. Then you will transmit and you will again call back the method to do the things after transmitting. Pre and post. Both these were the two callbacks. One was pre-tran, one was post-trans. These were the two callbacks from the driver. First, create this callback in your top level test, then call the callback task from the driver. After that, the driver can use a queue. It is not compulsory, but say it wants to do lot of callbacks. So it can have a queue to hold the callback objects. Say from the driver, I want to drop the transaction, delay, everything I want to do. And for these different callbacks, what I'll do, I'll create a queue for the callback objects. This I can do. These are the three steps: create, call, and have a queue. Some things which you have to note, that it is not compulsory that driver should have the knowledge of the test. You are having a callback in the top level test. The driver need not have the complete knowledge of the test. It's not required. It can also use generic class that can extend, that the test can extend. That is fine. No need to know the complete test. Then using queues to hold the callback objects. Why? It is not compulsory to use the queues, but when you use queues to hold the callback object, what happens? It will simplify your process of adding new object, because you have a queue lined up. It's a systematic queue. Objects will flow one by one, so it will simplify your own mechanism of adding new objects. Now I will show you a complete example of the callback. Let us understand. First, you need to create a callback. Then only you will be able to do the callback. So we will have a driver callbacks class. Here we will create the callbacks. Let me show you. This is driver callback. Here you have a virtual method. Virtual method, and the name is pre-trans. Here you can see pre-trans. This is before doing the transaction. Whatever you want to do, you can put. Or this method is virtual, right? That's why no code. It's as it is. Later on you can extend from this virtual class and do whatever you want. This is like an empty class. This is a virtual class. Here you are passing arguments, transaction, and say you want to drop the transaction. So you are passing a reference bit to drop the transaction. If the bit is 1, you will drop the transaction. If the bit is 0, you will not drop the transaction. That's how this can work. And the transaction, then whether you want to drop or not. In the post trans, you have the transaction as the argument. These are the two virtual methods, pre trans and post trans. These are the two callback methods, pre trans, post trans. Now I have a driver class. Inside this driver class, I'll have callbacks. Let me show you the code. Here I have the driver class. Inside the driver class, I am making an instance of this class, which is having the callback methods. I am creating an instance of this class. Driver callback is the name of the class. drvcb, this is the instance, and I am creating queue. You can see this is the queue of your callback objects. I told you, in order to simplify creating new objects, we can have a queue. If you don't know what is queue in System Verilog, there is a very detailed video lecture on queues which is uploaded in Switispeaks official YouTube channel. The name of the series is System Verilog tutorial series. You can go and check that series. It will give you the detailed description of the queue. Now, inside this driver class, you are creating an instance of the driver callback. drvcb is the name, and you are creating a queue. Inside this, I have a task run. In this run task, I am having a bit drop. This bit will tell whether to drop or not, whether the transaction should be dropped or not. You have a transaction class, you are creating an instance of that transaction. Later on, you are having a forever loop. You are trying to get the transaction from the agent. This method will get the transaction from your agent into the driver. Then for each object inside this callback, you are first calling the pre-trans. You are calling pre-trans. See, this is the pre-trans. Inside this drvcb. drvcb is a instance of this class, and inside this class you have this particular callback, pre-trans. Inside this there are two arguments, trans and drop. Here you can see the transaction and drop. This bit will tell whether to drop the transaction or not. You can randomize this bit. If the drop is not there, then you will call the transmit transaction. If drop is there, you will not transmit the transaction. If it is not dropping, then only you will transmit. And later on, uh, for each object, you will also call the post trans method. That's it. Simple code. You are having a class which has two callbacks. One is pre-trans, which takes two argument transaction and the bit which says whether to drop the transaction or not. In the post-trans, it takes only one argument, which is transaction. You have the main class driver, in which you are creating the queues of this objects. You are creating queues of this object. You have a task run in which you are creating the drop is a bit, it can be 0 or 1. You have the transaction, and you are getting the transactions from your agent. For each transaction, you are first calling the pre-trans and you are passing trans and drop, whether the transaction is dropping or not. If the transaction is not dropping, then only we will transmit. And later on, for each of this object, we will also call the post trans method. That's it. Simple code. With the help of very simple example, I explained you the use of callback. Main thing, I will not touch the driver code. Inside the driver code only, I'll just make a callback to the callback methods to do anything on the transaction, whatever I want to do. But the main driver code will not change. That is the main advantage of the callbacks. Now I want to do some error injection using callback. Let us see that example. Say I want to create a callback for dropping the transaction. How can I do that? Let me show you. First, you will have a driver callback drop. I am naming it like this. Extends driver callback. Remember, in the previous code I showed you, there was a driver callback in which there were two virtual methods. One virtual method was pre-trans, another virtual method was post-trans. Now we are extending from that class because I want to put some code inside that virtual methods. I want to put some user defined codes. I want to do something with that virtual methods. I want to really do something before doing the transaction. I want to do something after doing the transaction. Now this is the virtual task. It had two arguments, which was transaction and the bit drop. What I will do now inside this code, I want to drop one out of every 11 transactions. I will have 11 transactions. Out of that, every one transaction I want to drop. This is the code. 0 to 11, I am giving. In between these, at least one transactions is going to drop. So what I'll do, u random range 0 to 11, and I'll give 0. It means any one transaction from 0 to 11 will become 0. I am assigning the drop bit of any one transaction from 0 to 11 to 0, so that one out of every 11 transaction should drop randomly. And that's it. Simple, very simple. I am randomly dropping one out of every 10 transaction using urandom. Urandom is a urandom range is inbuilt provided by systemverilog, wherein you can specify the range. There is a systemverilog randomization series. Complete series is uploaded on switispeaks official YouTube channel by Sweetie Pinjani. There, if you want to go through, you can go through complete series. You will get an idea of various ways of doing the randomization. This is one of the way. Very simple code. We learned how we can drop one out of every 11 transactions using the callback. With the help of very simple example, I am trying to explain you so that callback is clear. I don't want you to have any more confusions in callback in future. Very, very simple. In the system verilog also, there are some methods, some inbuilt methods in system verilog to do callback. Examples are pre-randomize and post-randomize. In randomization, we had discussed, if you want to do something before doing randomization, you can call pre-randomize. If you want to do something after doing randomize, you can call post-randomize. These methods are inbuilt provided by system verilog itself. This is a example of callback methods which are already provided in system verilog. Very, very simple. To summarize, callback is nothing but a hook. You can consider it as providing you a hook to do something inside your code, say driver, without changing the driver code itself, without changing the driver code. If you want to add some additional code in the driver, you can do it with the help of callback. What we will do, we will create empty methods, dummy methods, and we will call those methods inside our actual class, say driver, and then you can extend from this dummy method to perform whatever you want to do. For example, you want to drop the transaction, so extend from this dummy method, call this dummy method inside your this driver class, and do whatever you want to do, drop the transaction, add delay, whatever. The main use of callback is, it is providing you a mechanism to alter your code of a component, of a test bench component, without editing the actual test bench component class. That is the main advantage. If you want, go through this lecture a couple of times, understand the coding example which I have shown you, try to write this code by yourself. After a couple of times, I am sure by yourself this callback will be very clear to you, and in future you will not be confused with callback. It is simple to understand, no need to complicate. Understand this properly, because callback is a very important concept in system verilog, and even in UVM we are going to use callback a lot. That is why I am telling you, understanding callback is very important. We have to use this thing. Please go through, understand it thoroughly, and in the upcoming lectures I am going to cover the more important concepts in system verilog, UVM, and a lot of other topics. To stay tuned, please subscribe to Sweetie Speaks official YouTube channel. Thank you, and